Hello friends, welcome to G-Centric. So in this lecture, we will see about the linear transformer. What do we mean by that? Okay, so now basically linear means we have seen already in our basic lectures that it should pass through the origin and it should be a straight line. Similarly, there are two definitions for this one where we have 1:1 ratio. Okay, turn ratio is 1:1, that we will call as linear. Otherwise, flux is directly proportional to current flowing in this coil. Okay, so these are the two definitions. Now we will see here that two dots are given over here. So where there is dot, we have to put a door. Okay, here is also dot, we have to put a door. Next we have to sit opposite towards it. Okay, we have to be here. Okay, so when we are sitting over here, we will see if the current is entering or leaving. So it sees that current is entering the door. It means that E, right? Then here also same thing, current is entering the door. Now both are entering. It means that M is positive, right? Mutual effect is positive in both the cases. Okay, we have here V1. Okay, here is V2. We'll rub this one. Okay, and the current is I1 and I2. Right, so now we will apply the KVL and write the equations. So if we have to write V1, okay, first what we have to do, this is the inductance, self-inductance, we will write that for the voltage L di1 upon dt, right. Next, because of I2, there will be a mutual effect in L1. So M di2 upon dt. Okay, so this is equation number 1. Next, similarly, we will write for V2. It means that we'll apply KVL over here. L2, it's the self-inductance. For which one? It is because of the effect of I2. Next, there will be mutual effect in L2 because of current I1. Right? So now I'll rearrange this V2. If I rearrange this one, I'll take this I1 over here. So first M di1 upon d2 plus L2 di2 upon dt. So let us call this equation number 2. Okay, so we have got V1 and V2. Now we will see the synthesis diagram. Okay, this is not so important, but still we will see the synthesis diagram for this one. Okay, here we will have coil L1. Okay, then we have the voltage source, dependent voltage source. Okay, and here we have L2 coil. Okay, so basically why this is voltage source? It is nothing but the di1 upon dt. Okay, or L di upon dt will give you voltage, right? So we will have here voltage source. So this is V2 and here the current entering is I2. Here it is I1 and here it is V1. So this will be nothing but what it will be? M di1 upon dt and here M di2 upon dt, right? So no, this will be di2. Okay, this will be di1 and here L1 di upon dt and this is L2 di2 upon dt. Okay, so this is the synthesis diagram. Now this synthesis diagram is in time domain. Okay, this is in time domain. So in some time we will see what will the synthesis diagram in frequency domain as well. So before that we can write this format in matrix form, right? So we will take here V1, V2. So this will be equal to, we have rearranged it already. Here it will be di1 upon dt, di2 upon dt, right? So in this space what we have to fill here? L1 M, okay, and M L2. Right? So this is in the time domain. So coming to the frequency domain, I will make changes over here itself. Okay. So basically d upon dt in frequency domain is nothing but j omega. So basically nothing but s, right? We will do it in Laplace transform. So this is the frequency domain because omega is the frequency involved in the Laplace transform. Okay. So now if the current is entering here, then this will change into di upon dt will change to j omega L1 and this current is already I1 flowing in it. So this also I can replace j omega M I2. Okay. Next here also j omega M I1 let us write in capital. Here also it will be j omega L2. Okay. Now we will write the equations for this one. Now to write the equations, we will apply the KVL. Okay. So how to apply the KVL for now? We will take this equation, okay, plus V1. This will be minus over here. Since we are taking it over to the right hand side, it will become plus. So this is j omega L1 I1 and this will be plus j omega M I2. So this will show minus, but when we take it over to the right hand side, it will be positive. So why I did not take I1 over here? It is because it's the already voltage source. Next, coming to V2, over here we have first we will write this equation, okay, j omega M I1 plus j omega L2 I2. Okay, so this is the equation. Now we can write this also in matrix form. V1 V2 equal to, this is I1 I2, right? So this is j omega L1, this is j omega M, here also j omega M, and here it is j omega L2. Okay, so this is the synthesis diagram for frequency domain, and the equations for the frequency domain is here. Let us call this as 3 and this as 4. And the matrix form here is V1, V2, j omega M, I1 and I2. Okay. Okay, so now till now we have seen up to synthesis diagram as well as the matrix form that we have written. Now we will take the T model. Okay, so this is helpful in the electrical machine part. Okay, so when it is helpful in the T model for the electrical machine part, so we will see here also. Okay, this is nothing but the T model that we have seen in the two-port network. Okay, T model. Now for this one we have got V1 and the current is I1, this is L1, this is L2, okay, plus minus V2 and this is current I2. So when mutual is involved in this one, so this will be L1 minus M, L2 minus M, and this is M. Okay, so in the matrix form, whatever we had seen just now, when you take the KVL over here, we will get the same equations 3 and 4. Okay, so now after this one, this is when M is positive, right? So when M will become negative, okay, so when M is negative, what we will get? We will get here plus L2 plus M, and this M will be in the negative domain. Okay, so this is about the T model which we will use it in the electrical machine part. Okay, when we have seen in the first video itself that we have taken it as 1:1 ratio, linear transformer. So the 10 ratio here is not considered. Okay, but in electrical machine we will include the turn ratio as well. Okay, so now coming to there is one more small topic in this linear transformer, that is inductive coupled, okay, inductive coupled coils. That means we have got here two types. In resistors, how we will see series and parallel. Here also when two series and parallel coils are connected, what will be the mutual effect? Okay, so in this we have got aiding and opposing. Okay, here also we have got aiding and second one is opposing. Okay, so next we will see here series aiding. Okay, our first topic is series aiding. That means we have the coils connected in series. So when these coils are connected in series, it means that the current entering for this is same. So voltage drop, total voltage drop will be V. Okay, let this coil be L1 and this coil is L2. Okay, next I will write the equations for this. Okay, so V will be equal to, okay, it will enter here L1 di1 upon dt. Okay, okay, let us not take I1 because the current here is same. di1 upon dt plus, because of current I2, there will be a mutual effect in this L1, that is M d I1 upon dt, okay, or due to this coil. So this is, we will just take the same current, okay. The dot's polarity will be over here. So when you see, both will be entering currents, okay. Here also it will be current I. Now coming to this L2 di upon dt. Because of this coil, there will be a mutual effect in this as well. So this is M di upon dt. So this V, I can write it as L equivalent di upon dt, right? Voltage across the inductor is nothing but L di upon dt. Okay, so this will be equal to, I'll take over di by dt as common. So what I will get, L1 plus L2 plus 2M di upon dt. This di gets cancelled and L equivalent will be L1 plus L2 plus 2M. Okay, this is when we have got series aiding. Okay, next coming to the series opposing. What we will get when we have series opposing? Okay, I'll not derive here, I'll just directly write the formula. Here we have taken one as entering, here also one as entering, but this dot will be over here. Okay, so the guest will be leaving. Now M is negative. Okay, so when mutual is negative, here you will get as, when it is series opposing, L1 plus L2 minus 2M. Okay, this is when series opposing. Next we will see the parallel. Let me rub this board. Okay, we have here parallel aiding. Okay, so when it is parallel aiding, how will our circuit look? Okay, two coils will be connected in parallel. This is here, and the voltage drop will be same in parallel, right? So this is V. Okay, then let us take this as current I. Okay, here there will be some current and here also it will be, some current will be there. Okay, so since M is positive, our L equivalent will be equal to, I'll write directly the formula, L1 L2 minus M square, L1 plus L2 minus 2M. So do not get confused with this negative sign. Okay, it is only when we arrive for the derivation, when M is positive itself, we will get this equation. Okay, this is when parallel aiding. So coming to parallel opposing. Okay, parallel opposing, what will be having? Dot convention will be just opposite to each other. So our diagram somewhat looks like this, right? Here is one dot, here is one dot. So one will be entering, one will be leaving. Okay, so here M is negative. When we have M is negative, our L equivalent will be, our numerator will be same. Here it will be positive sign plus 2M. Okay, so this is for parallel opposing and this is for parallel aiding. Okay, so this is about the linear transformer. In the next lecture, we will see about the ideal transformer and we will see some of the problems based on it. Thank you.